So our third and last speaker in this block is Kim from Stanford's Human Data Trafficking Lab. And she always says, we're not the ones doing the human trafficking, right? Kim.
Okay, well, thank you so much, Margot. What an incredible honor to join this panel of women, and indeed an honor to join this incredible community of women. I am delighted to have the opportunity to share some of the work of the Stanford Human Trafficking Data Lab with you today. And our lab is an academic research lab, but we work in very close partnership with key federal government agencies in Brazil who are tasked with enforcing Brazil's labor law. And that includes cases of child labor, it includes labor trafficking, it includes very severe cases of modern slavery. And together we work to build and evaluate new technologies and evidence-based interventions to help them do their job better, to intervene and detect trafficking more efficiently, and ultimately to impact the prevalence of trafficking in Brazil. So early on in our partnership, we invested quite a lot in formative work to really understand the roadblocks that frontline stakeholders face in doing their jobs of interdicting human trafficking. And the research that I'm sharing with you today addresses one of the key challenges that we identified in a very specific setting in Brazil. Okay, so I'm going to give you a little bit of background. Probably most of you in the room are keenly aware that Brazil is losing forest and biodiverse savanna at an alarming rate. And much of this land in the arc of deforestation is being converted to agricultural use. So in addition to being environmentally devastating, this process of illegal deforestation is rife with human rights abuses and modern slavery. And a lot of people don't know about that interaction. And it's quite difficult for law enforcement and regulators to intervene effectively. These sites are extremely remote, right? They're out in the middle of nowhere. Workers are very isolated. They don't have the opportunity to call in a tip or complain. There are no bystanders around that can do any kind of whistleblowing. So it's very hard to actually find these. If law enforcement does get a tip, most of the time it's very vague and non-specific in terms of the location. So somebody might say, it's like, there's a really shady guy, he's like 10 kilometers that way, and then you turn left at the third farm and then go, it's up in there, right? It takes them many days to actually locate the physical location of these work sites. And then workers may be moved around. These are seasonal operations, so they may be moved around very quickly. And in short, it's really hard to find these locations in general. It's a needle in a haystack, and it's hard to find them in time. So we need a technological solution. Okay, so our team identified a very particular type of worksite involved in the deforestation process that has a very unique visual footprint. These are kilns used to produce industrial charcoal from the cleared biomass. And here's a picture of what one of these sites looks like from the ground. This picture was taken during the time of a raid at which I think, if I remember correctly, 26 people were rescued from slavery here at this site. And this is what that site looks like from space. Okay, so you can see right away there's a very clear footprint. We have all these little white dots. Those are the kilns themselves. And then you have all these piles of charcoal in the middle. And as it turns out, that charcoal reflects light in a very different way from other surfaces, so we can not only take advantage of the pattern of the kilns themselves, but also we can use near-infrared spectral bands associated with our satellite imagery to actually identify the charcoal itself. And that's an important feature because it helps us learn which sites are active and which sites are not active, right? We don't expect to see charcoal hanging around a decommissioned site. Okay, so there's an opportunity here that's very clear, and we wanted to leverage that. Okay, so our team developed a tool that uses satellite imagery to locate these sites, and it has three main software components. The first one is a custom-built, high-throughput image processing software, which enables very fast execution over a large area. And when I say that, the state of Maranhão is over 300,000 square kilometers, and that's more than 200,000 image tiles that we need to process, and our model can run in under 12 hours, right? So then once we download all of that imagery and pre-process it, we have a CNN object detection algorithm that first classifies each tile about whether we think that there's a kiln there or not, and then localizes that set of kilns to draw a little bounding box around the array itself for a very precise location. The third component is a post-processing step in which all of our results are output and post-processed and then enriched with supporting data. And then we use that to populate a queryable geospatial database for inspection support and also scalable monitoring. Okay, so this database not only contains the cumulative archive of all of the kilns that we're monitoring and that we're identifying, but also attaches supporting information that is quite important to these investigations. So for example, is this kiln on indigenous land? Does this kiln have a permit? What is the parcel number for that location? Where's the nearest deforestation that's happening? All that information is incredibly useful for these inspections and helps us prioritize which ones are the most at risk. Okay, so all this is pulled directly from public databases. And two other features I just want to mention very quickly. We only rely on relatively inexpensive satellite imagery, about 3-meter resolution that we get from our partners at PlanetScope or at Planet Labs. And this is very convenient because you cannot run a scalable model if you have to commission very high resolution, expensive imagery all of the time. And second, our outputs are very simple and straightforward. And we do that in order to integrate seamlessly into existing case management workflows. That's very important. Okay, so what do those outputs look like? Well, obviously the first output, and how do these serve the investigations? We run our model, we find all these locations. Obviously, we can populate a map, okay, right? We can visualize where these clusters are occurring. And how big and what's the extent of those clusters. So this doesn't look all that exciting to those of us who are skilled at using Google Maps, but actually this doesn't exist before. They don't actually know what's going on in the ground. So just having it visualized in this way with precise locations provides a tremendous value to inspectors. Second, we can engage our model to support a specific task force as it's being prepared to provide pre-task force intelligence. Here's an example. You can see Site A in the upper right-hand corner there was actually a site that was inspected, and people were rescued from trafficking at that site. But inspectors didn't know that Site B and Site C existed, right? So there's a missed opportunity there to inspect all of these places at once. Probably they're all owned by the same person, okay? And the third output that we have is this kind of animated progression of the site that we monitor over 12 months to give them a sense of whether it's expanding and what's going on at that site. Is it active right now? Is it brand new? That kind of thing. Okay. So we launched our tool this summer in Brazil. It was very exciting. Everyone loved it. Everyone was really excited to have this information that was not available before. And our team was able to go down to Brazil to observe the entire process. What do they do with that information? How do they conduct their investigations? How do they select where they're going to go? And then we were actually able to accompany them on the resulting site inspection and raid. So this is what it looked like. It was quite successful. Trafficking was identified at the very first site that was inspected. These workers were not being paid any wages. They were being forced to live at the kiln site and feed the kiln 24 hours a day. They were living in these degrading, inhumane conditions. They were very isolated and they were unable to leave. And the guy who was running the site, known in the area as Little Beast, he has lots of history with trafficking-related offenses and actually violence. So it was quite successful. And one other point of success that I want to just shout out, which we were so excited about, usually these task forces take about 2 weeks to complete. Because of all of the information that we provided ahead of time, this task force the whole operation concluded in 3 days. Okay, so everything was done in 3 days, which is really important, so that eliminating that search time and all of that preparation is really able to save quite a lot of resources in a resource-constrained setting. That's a win for us, I think, for sure. Okay, so I'm going to just wrap up quickly here by letting you know that we are currently engaged in improving our model. Training data is always a problem. If you have no idea where these kilns are to begin with, quite hard to train an object detection algorithm to find new kilns, right? So that's a problem that was a problem for us to begin with, and so we want to improve the accuracy of our model as we accumulate a new corpus of training data. And also we're going to be engaging in an evaluation stage. We like to think our work is quite impactful, but do we really know that for sure? We're all scientists here, so we're going to evaluate that using a quasi-experimental study design and try to account for those spillovers as much as we possibly can. So I will just close by thanking our funders. We're funded by the US government Trafficking in Persons Office and Stanford's King Center. And also I'll make a pitch. We are looking to expand our project. So if you happen to know of any very talented data scientists that have an interest in doing some social good, come find me.